In the last video, we began customizing the source code for a standard CMS 9068 device by replacing its 9232 C-Series module with a different module, namely the NI9234, a 4-channel module with BNC connectivity. And just as a quick review, what we did is we created a new NI9234 module component that links to existing acceleration channels. Then we modified the device definition for our custom device to link to this new 9234 module instead of the 9232 module. But all the other components are unchanged. Again, we're going to leverage the existing channel component, its unit components, and the metric and instance components for this device. Now that those components have been created and uploaded into the server, it's time to start implementation of the device code. So let's go to our LabVIEW project here and navigate to the FPGA portion of our project. And the first thing we're going to do is remove all of these 9232s. And in their place, we're going to add 6 9234s. After the 6 9234s have been added, the next step is to synchronize them all on the project. These modules are synchronized by exporting the onboard clock on one of the modules and then using that onboard clock for all of the slave modules. In this case, I've chosen Mod 1 to be our master module. And every other module here will use that time base as its source. Now we're going to save the project, and we're going to move to our FPGA VI. Let us examine this for just one moment. All of the I/O nodes for the C-Series modules are inside of this API, BOP6. If we open this up, we'll see the configuration I/O nodes. Inside of here are the start I/O nodes. And inside of here are the read I/O nodes. And you'll notice that there are many cases. Because one of the features of InsightCM is that you can have some flexibility in your I/O. And this is where it's implemented. If there's one module inserted, then the VI returns data from one module and then pads it with zeros. And then for 2 and 3 and 4, etc. So our task will be to modify this to include the 9234s. Now the recommended procedure is not to actually modify this VI or this API, but instead to branch it and create your own copy. So let's look and see where this API is stored. It is stored on C program files, National Instruments. You continue through here, it's inside of this VIB API directory. So let's navigate there and see if we can find our library. And indeed, here it is. So what we want to do is open this library that has the entire API, and we want to say File, Save As, Copy. We're going to call this thing pretty much the same name, but we'll add 9234 to the end. And we'll make sure and add a copy of this library to our development project. A good place to save it is inside of the source folder of our development project. And once that's done, we can close some of the stuff. And here is our library. Let's open up one of these VIs and make sure that it's in our source directory and not linked to VI-lib, and it is. So just for ease, I think the next thing that we should do is go into the properties of the library, and let's edit the icon to be something different. So we're absolutely sure that we know which API we're interacting with. Okay, yes, I want to apply this to all the VIs. You can see all of these VIs here now have the red icons. So let's go back to our FPGA VI and let's start replacing this API with our new API. This will go here, this will go here, this will go up here, so will this, and so will this. I'm just going to position these real quick. And then we're going to wire it up. And we're done. The last step here is we need to go into this new API and now implement the code for the 9234. Now I'll go ahead and say that the starts and the stops don't need to be changed because the I/O nodes are the same between the 32 and the 34. But when we go to the config, for instance, this is only set up for 3 channels. So we're going to have to add a 4th channel to each of these rows here. This is going to be mod 1 AI3. This will be mod 2 AI3. And so forth. Now that that is done, we need to change this sample rate control here to be from 9232 to the 9234. This is actually a utility VI that comes with Rio. So I just need to go grab the version that is appropriate for the 9234. It's in C, Program Files, National Instruments, LabVIEW, VILib, LabVIEW Targets, FPGA, Rio, Shared, and it's the NI Rio data rate API. There should be one for the 9234, and there is. So we'll just drop this guy down here, and we'll use him instead. And we're done. The next thing we'll do is we'll go into here. Now, the 9234 doesn't support open and short detection, so we're going to have to delete all of that code, which was for the 32. Basically replace this with just a giant array of falses. We'll say there's 24 of them, because 6 times 4 is 24. And we'll wire it to both of these. Alright, we're done with that. And then the last step is to modify the read. Each of these cases. And we're done with that. It's not the prettiest thing in the world, but it'll get the job done. So if we go back to our FPGA VI, we've implemented each of these VIs, so all that's left is to build the bit file. We'll go back into the bit file here. As you can see, I added the text 9234 to the bit file name just so that I can differentiate it between the standard bit files. I'm going to hit OK, and I'm going to build. So I'm going to conclude here while this bit file is building, and once it is done, we'll finish our implementation.